Hello and welcome back to another video. In this problem, we're told in a normal respiratory cycle, the volume of air that moves into and out of the lungs is about 500 milliliters. The reserve and residual volumes of air that remain in the lungs occupy about 2,000 milliliters, and a single respiratory cycle for an average human takes about 4 seconds. We're asked to find a model for the total volume of air, V of t, in the lungs as a function of time. So, what we're going to do is we're going to model this with a trigonometric function, right? So we have the sine function, starts at 0, goes up to 1, down to -1, and back to 0. We have a similar thing here, right? Where we are starting at whatever this baseline value is. We are going up a certain amount of volume of air, and we exhale, it goes down, and it returns to the original value at some point. So the first thing we're going to do is we're going to say, okay, we're modeling V of t is equal to sine of t. Obviously, it's not modeled by just the normal sine function. We're going to apply transformations to it to actually get it to match V of t. So the first thing is the horizontal shift. How much do we have to shift the sine function to get it to match the starting point, the quote-unquote zero average value for whatever starting point we're going to choose. And the thing is here, we can see that V of t is not dependent on any particular starting point, so we're actually just going to ignore a horizontal shift. We do have a horizontal stretch. So a single respiratory cycle, right, this whole period, takes about 4 seconds. And the period of a sine function is 2 pi. So to go from 2 pi to 4, we have to stretch it by a factor of 4 over 2 pi, or 2 over pi. What this actually materializes in the function as is V of t is equal to sine of not 2 over pi t, but pi over 2t. Right? Horizontal stretches are a little bit weird in that you have to flip the factor by which you are stretching. Next, we have the degree of vertical stretching. So the volume of air that moves into and out of the lungs is about 500 milliliters. So that means the difference between the highest and lowest volume is about 500. The sine function in its usual state is from 1 to -1, which is a difference of 2. So we're going from 2 to 500. So we have to stretch it by a factor of 500 over 2, which is 250. And unlike a horizontal stretch, we don't have to flip the fraction. It's not 1 over 250, it's just 250 sine pi over 2t. And finally, we have the vertical shift up. So the reserve and residual volumes of air that remain in the lungs occupies about 2,000 milliliters. That means that the minimum value that we could have is 2,000. So when we are going from our function, which has been stretched accordingly, right? So it takes about 4 seconds, and it goes from, instead of from 1 to -1, it's going from 250 to -250, something like that. This minimum value of -250 now has to be 2,000, right? So we are raising it up 250 plus another 2,000, so it's V of t is equal to 250 times the sine of pi over 2t plus 2,250. And this is your function V of t, which represents the volume of air in the lungs as a function of time t.